So as Jose said earlier, our first talk today is focused on some Apollo keynote invited talks, as well as some updates from our headquarters colleagues, as well as the chair of the Artemis 3 science definition team. So we're hoping that these four initial talks kind of set the stage for the rest of the workshop. We're really excited today to have our first speaker, who is a person who really needs introduction, but of course, Dr. Harrison Jack Schmitt was, one of the scientists astronauts who walked on the moon, the only one, in fact, and he's going to be providing us with some insights and thoughts of his experience, not only as a scientist astronaut, but as well as a scientist who was supporting the Apollo program in general. So take it away, Dr.
Well, thank you very much, and good morning to everyone. It's great to be with you. I see a lot of familiar names there. I was thinking of Caleb, and I got a new name, a new date for Camelot. Caleb, we'll have to talk about. Next slide. The science backroom history is really quite colorful. It's nice to relive it. Gene Shoemaker really came up with the concept when I and Gordon Swan and others were working with him in 1964-65 before I entered pilot training. And once I'd gotten through the training phase and we were actually working to get Apollo 11 put together and planned, I suggested to Gene Kranz that he talk to Gordon Swan about the studies they had been doing, which were related to science support rooms out in Flagstaff. And Swan and Kranz got together, and that really, I think, was the germination of the Apollo 11 science support room, which was carried on throughout Apollo. Apollo 11-17 near real-time air-to-ground transcriptions was probably one of the greatest contributions that came out of the survey's involvement, Gordon Swan in particular, in that he suggested that we use court recorders to put a near real-time transcript up on an iodophore in the Mission Control Center. And that indeed was done, and so that at that point, Mission Control and everyone else had a transcript that was only about 30 seconds behind the actual transmissions. Apollo 11 activities of the SSR were not major, but one of the things was, where in the world did they land? As you all may recall, Neil had to translate down range quite a bit. We were not totally familiar with the mascons at that time and how they were perturbing the orbits. And Swan and his team finally, I think it was about 3 weeks later, actually were able to, through examination of photography taken by the crew, find the location of the landing site. Apollo 12 and through 17, there was increased interaction, particularly with Capcoms, and in 15 and 17, there was particularly a great deal of EVA replanning. And that generally went well. We'll talk a little bit more about that in a few moments. That experience, those support room activities were indeed transferred on to Skylab shuttle and the International Space Station. Next slide, please. Now, what are the advantages of having a science support room? They probably really haven't changed very much from when we first conceived of it. It certainly relieves the flight director and Capcom of making the science trade-off analyses that often will be required based on either time constraints or actual hardware problems or what have you. It brings those, namely the scientists with the most interest in the results, into the action. And I think we can, as I'll talk about a few moments, I think we can do more of that. Provides a mechanism for interaction between science and the operations and engineering support rooms. They were all in the same building and presumably will be, in fact, so you could run down the hall and discuss overlapping interests at any time. And it was particularly important support for long duration Lunar, and Mars missions to provide advanced exploration recommendations based on previous findings. We did some of that, particularly on the last 3 missions with Apollo, but as you well know, the longer you're going to be on the moon or eventually on Mars, that kind of planning related to the findings of the previous day or the previous week is going to be increasingly important. Next slide. Now, let's just, I hate to talk about problems, but we did have problems. And I'll primarily focus on Apollo 17. One of the ones that was most frustrating to the crew was the reluctance of the SSR to give up on the surface electrical properties receiver. It had not been designed properly for thermal or for thermal protection or resistance. And although it did get data on the first and second EVAs, it did take up a lot of time with the ground when it was clear that it was not recording any longer. Also, there was a belief, I think, in the science support room that the PI for the lunar surface gravimeter, which really was a gravity wave detector, had adequately tested the uncaging of that instrument. And I was disappointed in the disinterest that was shown in a suggestion that we tilt the experiment away from level in order to get that beam uncaged. And there was also a recommendation, I believe, from the science support room to depart from our established routine of 2-man operations at Station 3. Now, those are just the personal ones that come to mind that bothered me the most. There also was an issue we'll talk about maybe a little bit down on this slide of there being no control over the use of the television. And the television often had wandered off looking at things that had nothing to do with the immediate issues that needed to be addressed. Now, on Apollo 12, crew reaction to the Apollo 11 science criticisms was really too bad. Scientists have got to keep their personal feelings about the use of various terms to themselves. The crew can react to these kind of things. If you have a geologist on board, the geologist doesn't really care about that. But people who are not used to scientific interactions will react differently. And in this particular case, there had been scientific criticism of Buzz Aldrin's use of the term mica to describe what the sparkly surface looked like. And indeed, it looks like it's got mica in it. The crew had seen this kind of phenomena on their various field trips, mica sparkling in stream beds and the like. And some scientists criticized them because they said, no, there can't be any mica on the moon. Well, that's ridiculous. It looked like mica, and that's what we asked the crew to do. You've got to remember that kind of thing. Apollo 14, there was lack of real-time tracking, which hopefully we'll have on Artemis, and that led to a crew missing the crest of a major crater objective. They basically got there, they just didn't know that they got there. Apollo 15, the science support room missed the importance of the discovery of green ash, pyroclastic ash, and almost certainly at Spur Crater, we could have gained some of the insights that ultimately we gained on Apollo 17 at Shorty Crater. There was a lack of operational understanding by scientists and their engineering support. And this was particularly in the early days of putting together the ALSEP. ALSEP deployment was far too complicated, should have been much more automation involved in it. Those kind of ideas came in too late into the program, and the astronaut office bears some responsibility for that in asking the Bendix folks to make sure that we had something to do on the moon, as if there wasn't going to be much to do on the moon. The lack of SSR participation in geological and ALSEP simulations, I think, was a major problem, and I would strongly recommend that once a mission crew is assigned, the simulations are going forward, whether they're run in mission control or actually out on geological problems. The people who are going to man the SSR should have very close participation in those kinds of exercises. I think it'll pay off handsomely in the future. And then, as I already mentioned, the TV's support of EVA activities was not very good, and the television operators also should participate in these field simulations so that you get much more continuous, much better coverage of the things that are important scientifically. Next slide. Now, good results, of course, during Apollo were many. EVA replanning overnight usually went very well. In the case of Mars, of course, that's probably going to be planning over several days. But overnight planning went well. For example, there was a lot of discussion, as I understand it, about going back to Shorty once I discovered the orange soil. And giving up on Van Surg. I'm certainly glad that they did not do that. In fact, I'm currently working on Van Surg samples, and they're really very, very interesting samples that we wouldn't have gotten had we made that decision. You've got to basically believe that your pre-planning done in the quiet of the evening in the crew quarters and various other places is going to be very good, and particularly with the LROC coverage of the moon now and any landing site that we go to, that pre-planning ought to be your default decision anytime something comes up. It doesn't mean that you won't take advantage of some new discovery, but be careful that you change those original plans until you have enough information to feel that such a change will be worthwhile. Apollo 17's reallocation of time, shortening of the drive to Station 1 was important. The ALSEP just took, as always, far longer to deploy than it should have. And then the deletion of Station 10 was an excellent decision, it turns out, because we already had good coverage of the Mare basalt geology, primarily from Station 1, but also from other samples that we had taken. Next slide. Now, I just suggest that slight reorganization of the SSR in support of the missions. This diagram you can later study at your leisure. It should be kept simple. The experiment anomaly evaluation is something that was probably not well done in the Apollo system. I was not there, and Jim Head later on may be able to discuss that in more detail. But we had I've already mentioned the two major experiment problems we had on Apollo 17, and it just seemed to the crew, at least, that there was a great deal of spinning of wheels in order to come up with decisions that ultimately cost exploration time. Discovery response team, primarily made up of field geologists. I think it was important in that, for example, when I discovered the orange soil at Shorty Crater, there really was not a mechanism by which the SSR could participate in the sampling and other kinds of things that we did there. There was a little bit of spinning of wheels, and so the crew basically took charge in real time. We didn't have a lot of time. We only had about 30 minutes at the station. And in the final analysis, we did, I think, a pretty good job of getting the samples, having spent a lot of time looking at the data that came from those samples. One sample was missed, and it's too bad that either I or the ground did not realize that we had not gotten one of the samples that we should have, and that was the pyroclastic ash sample next to the light gray regolith that had covered that ash and protected it. Real-time transcripts, that obviously now can be automated, but it's still very important to have. And whether that's a function of the science support room or mission control itself is something to be worked out. and you need to have a team that is continuously and very rapidly keeping track of the sampling and the feature documentation that has taken place on any particular EVA. And then the same goes for making sure that your samples are all properly identified. I don't think on Apollo 17 we missed any identifications of samples. I'm a little bit concerned about the numbering of samples in the trench I dug at Station 3. But the more I look at it, the more we may have actually gotten that right. They're just, those samples are complicated, and it's something I'll continue to look at, particularly in the context of the ANXCA examinations that we're undertaking at the present time. Next slide. And with that, I will either give back my time or take any questions you might have in the remaining 5 minutes.
Thank you so much. Wonderful talk. I think it really sets the stage well for a lot of the discussions we're hoping to have in the breakout. So thanks very much for those perspectives. I think we do have a couple minutes left. So I think if you guys have questions for Jack, I think we should not hold them for the Q&A. So please feel free to put them in the chat. Jennifer Heldman from NASA Ames has a question for you, Jack. She says, fascinating talk. What do you think are the major differences, if any, with respect to the SSR for longer term lunar and Mars missions via the SSR for the shorter duration sortie type missions?
Well, the SSR for long duration missions is going to be much more involved in the planning of EVAs once you have some basic information about the site or the traverse that you have taken. And that's particularly going to be true, of course, for Mars because of the communication issues. The crew is going to be much more autonomous on Mars, and I think that the autonomy should be added into the longer duration Artemis missions as well. But having said that, I think you have to be set up in order to do the kind of in-mission planning that will be done pre-mission based on the new information that you get. And presumably on these longer missions, you'll also be getting analytics about materials on the moon that we were not getting in Apollo.
Great, thanks. Kind of a follow-up question to that, I think. Bernard Foy asks, how do you see any changes playing out in the planning and interaction with the crew for the 8.5-day conceptualized Artemis missions? So kind of the middle ground between what Jen asked.
Well, I would like to see ways in which scientists, particularly geoscientists and field geologists on the ground, will have an opportunity to have sort of calm discussions with the crew and not through intermediaries. The Capcom can be involved, but I think there ought to be direct communication, particularly after some particular unexpected discovery has been made. That I think would be extremely useful, particularly if you have a geologist on the crew. And of course, I'm recommending that every crew have a field geologist.
Thanks a lot. We also have another question from Marufa Buyan. What locations do you suggest for human settlements on the moon?
I'm sorry, say again?
What locations do you suggest for human settlements on the moon?
Well, I think the first human settlements will probably be related to resource recovery. And so that's going to be pretty well to control where the company town ends up.
Makes sense to me. Okay, a question from Brad Blair. What kind of human operations do you envision that bridge the gap between ISRU and the lunar resources you just mentioned and lunar science and solar system history?
Well, I think once you have a clear-cut settlement or a long-term base on the moon, I prefer settlement, then it will be a base for a great deal of scientific exploration. That will be one of the advantages of having a settlement, is that you can plan long-term exploration. Almost certainly some of that will be done by hoppers. Some of it will be done by long-range vehicles. of various kinds. I tend to prefer the vehicle, but I'm sure others will prefer hoppers, as we discussed, even for Apollo. No, I think a central location on the moon with access to other parts of the moon is going to be extremely important. For example, the deployment of a radio telescope on the far side of the moon that almost certainly could be handled from by multiple stories from a base which had continuous communication.
Great, thanks a lot. Alexander Miller, I do see your question. Let's save that for the Q&A, and hopefully Jack can stick around for that, because I think Alex's question is great, and the other speakers in this session might also have some thoughts on that. So thank you very much, Jack, for that talk. We look forward to hearing your perspective later in the workshop.
Well, thank you for the opportunity and for dealing with this extremely important topic. Thank you.
Thanks very much.